Great. Hello, everyone. It is a pleasure to have you here. I see that we already have some participants joining, and the numbers are increasing. So while we give folks a little bit more time to connect and to deal with the unavoidable technical difficulties that we all are very familiar with, I wanted to welcome you to this webinar on a very niche topic, right? Fuel fire heaters, which is something that folks do not understand very well, but this is exactly why we're here today, trying to close some of the knowledge gaps that exist on this and giving an opportunity to have an open discussion with the experts in the room and yes. So if you allow me, I'm gonna share my screen so and take the chance to introduce the ICCT. Given that when I was looking at the list of participants, there are many of the organizations and persons that I'm not very uh, not yet well familiar with. So, okay. So, my name is Felipe Rodriguez. I am a program director at the ICCT, the International Council on Clean Transportation. And I'm happy to introduce a little bit about the ICCT, right? So, the ICCT is an independent, nonprofit research organization. We play a pivotal role in advancing clean transportation globally. Here in this figure, you have a quick overview of where we have staff on the ground. So we have 6 offices around the world, 2 of them in the United States, one in Washington, D.C., one in San Francisco. We have the Berlin office where I am based, coordinating all of our European activities. We also have an office in Beijing, where my colleague Shiyue here in the call is. So thank you for joining so late. We have an office in Delhi, in India, and one in Sao Paulo. In addition to that, we have a few staff in other regions, Vietnam, Indonesia, Colombia, and Mexico, to mention a few. And the other colors that you see here are regions where we're actively doing projects, right? So just as a taster of the footprint that we have at the ICT. So what we do is we conduct research, we provide technical expertise, always with the objective of informing policymakers and to close knowledge gaps, reduce information asymmetries, to be able to reduce greenhouse gas emissions or air pollutants from the transportation sector. This is not only the road transport sector, but also marine emissions, aviation emissions, and the fuels that power all of those sectors. We have a staff of about 180 now, pushing towards 170 now, pushing towards 180 people. We're present in 5 continents. We do a lot of research and publications. So if you have the time and want to navigate through our website, there is a lot of material for you. And we're active in many policy processes around the world. So with that short introduction, just wanted to mention today what we're doing, right? So we're gonna have 2 presentations to set the scene. My colleague Shiyue Mao from the ICCT will present on the pollutant emissions perspective from fuel fire heaters. We're gonna hear from Katrina Sutton at CalSTART on the efficiency perspective of fuel fire heaters in electric buses. And then we're gonna follow that with a panel discussion with experts whom I'm going to introduce right before the panel, but you can already see the names here. All right, so over to Shiyue. He is a researcher at the ICCT, has been with us for a number of years now. He's an expert in diesel and electric heavy-duty vehicles in the Chinese context and has been the project manager for this testing that we did on fuel fire heaters in an electric coach in China. So over to you, Shiyue, for your presentation.
Thank you so much, Felipe. So let me share my screen firstly. Okay, so everybody can see my screen now?
Yes.
Okay. Hello, everyone. Good morning, good evening, good afternoon to everyone. My name is Shiyue Mao, a researcher from ICCT Beijing office. Today, I'd like to take you through a very interesting topic, the fuel fire heater, a heating device on the battery electric buses. So first and foremost, what is fuel fire heaters? On the left-hand side, it is an inner structure for a typical fuel fire heater on electric buses. While it's an heating device on electric vehicles, you can imagine it as a mini boiler, which burns fuels in the chamber and deliver heat to cabin in winter. It has very simple structure and straightforward control logics when using it. Once being turned on, the heater is working until preset temperature and it turns off. All right. So it's usually installed below the passenger compartment, especially for electric buses and coaches. It's installed at the back of the vehicle. Which I will show later. Due to its small size, there's usually no emission control equipment available, and actually that's where the problem comes from. So then what's the global policy landscape looks like to this field, to this device? This table just summarizes the key information by regions. In some major markets like California, EU, and China, there are some existing regulations to mandate the emission, and they just set a limit to some key pollutants. However, most of which were enacted somehow a decade ago and turned out to be outdated. Secondly, some important pollutants such as particulate matters, NMOG, hydrocarbons, are still missing from some regions' regulations. For example, in China, the regulation only covers NOx, carbon monoxide, and hydrocarbons. For California, hydrocarbons and PM are missing, while for EU, PM was regulated by smoke number, which is not a very accurate method. So it should be noted that these standards are incomparable across regions due to different metrics. You may already find that in China and the EU, they are regulating in ppm, right? Which means part per million, while for California, it is in gram per mile. You may also be curious about why China has a much more stringent limit than EU in this table. That's because EU controls the peak value through the whole testing period, but China applies to the average. Right? So again, these standards are incomparable in numbers, but can present what kind of pollutants have been managed in these leading markets. So by seeing this, we can say fuel fire heaters turn out to be a new challenge to current emission regulatory framework by three reasons. The first one, the heater has no emission from vehicle tailpipes, which makes it beyond the radar of most pollutant emission standards. Second, fuel fire heater as a heating device usually being retrofitted to vehicles after being sold in second stage manufacturing, which makes it more difficult to track the real world performance. And lastly, fuel fire heater is an increasing challenge to zero emission vehicles because in winter, people want to extend the available range, but the air conditioning system is so energy consuming and the available range would be much shorter than expected. And there's no recycled heat from engine to cabin like a conventional internal combustion engine vehicle. And so that's why we want to explore the emissions from fuel fire heater this time. So let me briefly introduce how this test was scheduled and set up. Firstly, we managed to find a popular bus model in China, or more precisely, it's a coach. I put the specifications table here. It's 18 tons with maximum capacity of 52 people, electric with battery capacity at 338 kilowatt hour. And I also showed the position that the fuel fire heater is usually placed. Just I mentioned that it's always be placed at the back of a coach. So this slide shows the setup information about the fuel fire heater. This heater is installed on the bus by the manufacturer, so it's not retrofitted. This heater can output up to 35 kilowatts with diesel consumption about 3.6 kilogram per hour or 4.24 liter per hour. So from the perspective of the fuel consumption and power output, we can say that's a very powerful heater on the coach. So in this study, we also scheduled tests at different temperatures, namely 20, -7, and minus 20. In the test conducted by heater manufacturers, a heater is usually tested at 20 degrees. It's at room temperature. So we also follow the procedure. Firstly, in this case, we tested with the vehicles running on the chassis dynamometer and in idle conditions as well. We had these tests at 20 degrees to collect some benchmark data. In addition, we also want to quickly check if the heater is truly working independently to the bus. And it seems true. The working conditions between the bus and the fuel fire heater is fully decoupled. And after that, we tested in idle conditions for -7 and -20 degrees. We turned all heating functions on with maximum airflow. We tested a couple of pollutants, including NOx, carbon monoxide, hydrocarbons, solid particulate numbers, or SPN in short. We particularly tested two types of SPN, the SPN10 and SPN23, which means number of particulates with a diameter greater than 10 or 23 nanometers. We also tested greenhouse gases like CO2, methane, and NO2. So the final results seems impressive. In short, we found that in this particular case, emissions from the heater exceed limits of regional regulations. For example, the NOx emissions at -7 and -20 degrees is about 18 times higher than the limit of the California's LEV second ULEV standard. Also for NMOG, the non-methane organic gases, the emission is also more than doubled to the standard at room temperature. So here's something need to be noted that we found it very difficult to test or to examine the actual concentration of NMOG at -7 and -20 degrees due to condensation in the tube. So we finally didn't show this number here. And similarly, the emission from this heater also exceeds EU's limit in carbon monoxide and China's vehicle pollutant emission standard in SPN 23. Here, I would like to clarify here about this China GB standard. It's different from the other one, the JB/T, which is specifically for fuel fire heaters. The China GB standard, or more commonly known as China 6, is for diesel heavy-duty vehicles. So we put the standard here Just want to illustrate that the heater is multi times more polluted than the diesel engine with similar power configuration on diesel trucks. In terms of the particulate matters, if we didn't try to control it with after-treatment technologies like DPF. So based on the information on the previous slide, we simulated the potential impacts from a heater on the electric coach in this study. You can see on the left-hand side, the blue bars show emission from the heater, and the red bars show the data for the coach. We assumed the coach driving by 180 kilometers per day, which is the average daily travel distance for coaches in China. And we use the latest carbon intensity of power grid as 620.5 grams CO2 per kilowatt hour. In that case, the fuel-fired heater may account for about 50% of the total CO2 emissions associated with the electric coach while in use. Or in other words, the heater is almost the same to the electric coach itself in terms of CO2 emissions in this case. If the heater counted in, the total CO2 emission would be 190 kilogram at -7 and 210 kilogram at -20 degrees. And we can find it's even worse. The share of the fuel-fired heater may increase due to lower carbon intensity of the power grid in the future. Right. So to wrap up, here are some quick takeaways. First, the current regulatory framework is inadequate to mandate the fuel-fired heaters. More pollutants and greenhouse gases could be taken into account. Second, this study found the fuel-fired heaters are heavily polluted, especially for particulate matters and NMOG. The heater is more polluted than a diesel engine with similar power output if no after-treatment equipment to be installed. And lastly, the heater emits almost the same CO2 to the electric coach itself. And the situation may be even worse due to cleaner power grid in the future. And based on the tests and analysis, we also propose 3 recommendations. First, we need to expand regulations to engage more pollutants, as currently no regulatory framework around the world is sufficient. Second, it is necessary to integrate this device into vehicle type approval procedure. The emissions from fuel-fired heater is non-negligible. We shouldn't keep it out of the certification procedures. And lastly, we are looking for more tests and data. We are very surprised to learn the fact that there were very scarce studies in this field by now. More tests can help update emissions inventories and design science-based policies. So all information I just mentioned above is coming from our recent publication, just I show you here. If you are interested in, you can refer to this paper from our website, the ICCT.org, or you can use the link. Yes, I would like to thank you again. Thank you for your attention, and please leave your questions in the Q&A panel. Thank you again. Yes.
Great. Thank you, Shiyue, for that presentation. We already have one question. I'll keep that for the panel discussion. Well, thank you for that. So if you do have questions, please put them in here in the section that we have for Q&A, and I'll make sure to ask those during the panel discussion. Well, next we have Katrina Sutton. Katrina, thank you for being with us today. Katrina is a technical project manager at CalSTART. I hope that you can introduce your organization a little bit as part of your presentation. Katrina supports the expansion of zero-emission buses mostly. She has a background in science and transportation technology from UC Davis and has a lot of expertise on charging behavior and fleet electrification. So we're very happy to have you with us here. And please, why don't you go ahead and share your screen and start with your presentation.
Yes, awesome. Thanks, guys. Good morning, good evening. I'm in California, so It's a little early for me, but that's just part of the fun. I'm trying to pretend I haven't used Zoom in a while, so please be patient. All right. How does that look? I'm gonna assume it
Yes,
looks
perfect. We see it.
beautiful. Love that. Okay. Yeah, thanks for inviting me. As Felipe said, my name's Katrina Sutton. I work for CalSTART, which is a nonprofit organization. We're based here in California, in LA, but we work collaboratively across the globe. I primarily work in the States, but always having a good time doing all sorts of fun tech projects. I do a lot of demonstration projects, data collection and analysis. CalSTART as a whole also does policy work, sort of driving people together on the global scale, and a whole host of other things that I will not bore you with because I don't want to say something incorrect. But today I just want to give you a little bit of an overview of what I've been working on in the fuel-fired heater space, specifically looking at electric bus efficiency. Shiyue gave a really great overview about the sort of the emission side of things, and I'll talk about that for just a moment, but I really think the interesting part is looking at how the heater impacts the bus efficiency to make sure that the buses can do their work as they need to when they leave the depot in the morning and make sure that they can provide comfort for the drivers, the passengers, and not get stranded somewhere because of in the cold weather. So this has already been talked about, but I have a slightly dirtier picture of an auxiliary heater here. But the definition from the CARB perspective, so the Air Resources Board here in California, really emphasizes that the heater is for warming the compartment for the passengers and doesn't contribute to the propulsion of the vehicle. The examples that I have here in the States is showing the fuel-fired heater here in red. With the red circle is the heater itself. It's very dirty. It's a working guy. And then the one in the circle in the yellow is actually the fuel tank. And that has I tried to translate the gallons to liters. So if the sig figs are a little bit off, I apologize. But it's 11 gallons and it's 42-liter tank, which is pretty large in my opinion for such a small heater, but just something to note. Um, California has an innovative clean transit regulation, so all buses are supposed to go zero emission by 2040, either battery electric here or fuel cell bus, as the case may need. So it's just something to keep in mind. Even though California is mild, there are still some places that would like auxiliary heaters. This is just a super fast overview of the different heater manufacturers and sort of their fuel consumption and power output. We find that on average it's about a 30 kilowatt power output. I know Shiyue said that their heater they were testing was 35, so that's roughly about what we see here. So it's just something to keep in mind when you have keep a number in your head. And then the fuel consumption is obviously dependent on the set point, but we expect it to be about a gallon an hour of usage. So just more numbers to keep in mind. Yeah, so I think it's really interesting that the auxiliary heaters here, despite the fact that they do not propel the vehicle, are still under a light duty vehicle standard per the Air Resources Board. So that's just what's highlighted here. I think it's really funny that it's it's calculated in grams per mile, despite the fact that there's no mileage being put on the engine, if you will, the the heater here. So I always just think it's kind of amusing. There's no PM testing, as was mentioned before. But the other thing that I found interesting from the California perspective is that the heater testing is only required if the heater is going into a diesel engine vehicle. So I focus a lot on transit. So if the heater is put into an electric transit bus, technically there wouldn't be any need to do compliance testing in this way. I just think it's kind of an interesting subset. It seems unlikely to me that somebody would do that because the market is sort of small, but just something interesting to note. So this is a little bit of data. I won't go into the weeds here. This is data we received. I did not go out and test it on a bus, but this is showing that these particular heaters are well below the California average. So they aren't having problems here. Obviously, the case may vary based on different manufacturers and also different, I don't want to say duty cycles because it's like a heater, but think about duty cycles here. Um, so this slide and the next slide, it's a lot of words, takes me a little bit to explain, but I promise it's super interesting. So just to keep in mind for everybody, efficiency numbers, the lower number is the better one. So keep that in mind because I'm showing low numbers and that's a good thing. So we find that the heater can either be used as a primary or a secondary heating source. So depending on when it's cold, sometimes the bus will start with the electric resistance heater and then pop in the fuel-fired heater as needed, or it will actually swap. We find that swap point to be about, I think it's 40 degrees Fahrenheit, which is pretty cold. 40 degrees Celsius is not cold, so I'm trying really hard. Keep that in mind. I'm reading my notes here, I apologize. So yeah, so this first number, so we looked at some data in the Midwest, which is pretty cold, on a 60-foot Arctic bus, which is the one with like the accordion in the middle. So he's very talented when he moves around. And we found that it uses about 30 gallons of diesel per bus per month for heating. And so that means that the extra energy, there's no extra energy being pulled off the traction battery, so that energy can be used for actually operating the bus. And so without the auxiliary heater, we found that the bus would likely have needed an additional 1,800 kilowatt hours per month just for heating. So a bus trying to pull an additional 1,800 kilowatt hours would be crazy. The whole bus would just be a battery, and then there would be no room for passengers. So what were you even doing? You're just moving batteries around, which is silly. So we find that the heater is actually, have to be really careful. The heater is decreasing, or the heater is increasing efficiency by about 0.44 kilowatt hours per kilometer, 0.71 kilowatt hours per mile, whatever you speak. So it's just really interesting to be able to quantify the effectiveness of the heater on the overall bus. We did this again for another transit agency in another cold region, which is a 40-foot bus, so more of your standard transit bus. With the heater, we found that there was a savings. Wait, let me look at my notes. Sorry, it's been a while since I did these slides. I apologize. Yeah, so as you can see here, the Midwest Transit Agency is more interesting in my head because it's like a very significant amount of heat. And then the mountainous transit region here we have here, you do see an impact in efficiency with versus without. So you can see the impact that the heater has just from a straight efficiency standpoint. Obviously, I didn't look at the emissions here, but if the bus can't operate, then you're going to have to think of something else and you'll have to probably run a diesel bus. So there is some trade-offs here. This is a new slide, so bear with me. This is part of some new research I've just semi-finalized. It's still in review here, so it's a lot of numbers and it's not very exciting, so I apologize. But essentially, we got some additional data from other transit agencies across North America and compared it to a semi-recent study from NREL, and we were trying to quantify the different drive efficiencies across the various cold weather temperature that the transits were seeing. I put hot in quotations at the bottom here because it wasn't hot, but it's in comparison to the others. So we actually found that there's a spot here where it is seeing the most efficiency. Here at cold, which we defined as, I guess, 4 to 10 C, where the bus was seeing the most efficiency, which was pretty interesting because you can see a big drop when it gets below 4 C. So there is some sort of inflection point here. Noted though, we are missing a data spot here at here in the cold section. So if we had that number, it could also change the data all over again. As we all know, everybody loves to play with data, and it's always a good time with your Excel spreadsheets. You know, always looking for more data and trying to get a better handle on these heaters. So that's about it for me. You know, the CARB, the EU, and the China standards, there definitely needs to be some synergy across to make sure that we are capturing emissions efficiently. I found that the emissions are significantly lower than the standard from the CARB perspective, so I'm actually very curious. Always kind of fun to hear about heaters and other people's research. Right now, I am actively running a study in the States looking at an interesting bioethanol catalytic heater as a comparison to the existing auxiliary heaters that are obviously run by diesel. So right now we're running an electric resistance heater, a bioethanol heater, and a fossil fuel heater in the same transit agency. So it's the same climate, roughly the same drivers, the same routes. And so we should get some really interesting data to do a good as good as you can sort of comparison when the buses are actually running. I really like doing demonstration work like this, so I'm really looking forward to this data. This work was also funded by the Federal Transit Administration, so just thanking them for that, their support on that, and that's all I have. So happy to keep chatting.
Great. Thank you, Katrina. I think that was very interesting. And now we can move to the panel portion of our webinar. So we have the pleasure of having today, in addition to Katrina and Shiyue, whom I already introduced, we have Kieran Humphries from Environment and Climate Change Canada. Kieran is a project manager and mechanical engineer at ICCT, specializing in advanced vehicle technologies and emissions research. Kieran has over a decade of experience in vehicle electrification, diesel after-treatment systems, and currently works with the Air Quality Research Division of ICCT and has a master's degree in mechanical engineering from McGill University. And we also have Cheryl Caffrey. Cheryl is a very seasoned mechanical engineer with over 30 years of experience in emissions research and regulatory development. Until recently, Cheryl was at the US EPA. There she led a lot of projects and supported many emission rulemaking through of course, the testing and the analytical side. If I understand well, you're also a very prolific author in SAE, for example. I run into a lot of your papers when I was doing a little bit of research around your background, Cheryl. So we're very happy to have you join us today. So maybe staying with you, Cheryl, if maybe you could give us your reaction to the results that you saw today from Shiyue and from Katrina, and whether that aligns with what you have seen on the field on the emissions performance of fuel fire heaters, and from your experience, whether this is an emission source that it is well understood and well quantified.
Sure, thank you. It's great to be a part of this panel today. I must say that Kieran Humphries and I have been working together for the past, I don't know, 4 years or so on this topic. So we have a lot of knowledge and we could probably talk for hours. But yeah, so a couple of comments. One is that I think the emissions that Katrina was showing in terms of relation to the California standards, that was from and Katrina, correct me if I'm wrong, was that from the certified fuel fire heaters to the California standards? I think there is a list. But it's our understanding in our testing that Kieran has performed is that the smaller 5.6 kilowatt heaters do show emissions lower than the CARB standards, but the larger fuel fire heaters like 23, or we haven't tested, or Kieran hasn't tested the 35, but at least the 23 kilowatt heaters that have been tested are higher in terms of yeah, I'll leave it at that, higher than the CARB standards.
Part of that is the way the standard is written, right? In that you're looking at the grams per mile, or effectively assumed mile that it travels, there's no consideration of how much power or energy the heater's actually putting out. So if you have a larger heater, it's going to produce more emissions, and then you're going to get a disadvantage on that standard. Just my 2 cents there.
Yeah. So California standards are just one number for no matter what size of the fuel fire heater. The other question I had, maybe the point of discussion, is that the emissions that were shown in Shiyue's presentation with the fuel fire heater, specifically the greenhouse gas CO2 numbers, where the fuel fire heater is 53% or 50% of the total compared or or to the diesel exhaust. These fuel fire heaters are used on diesel powertrain vehicles as well. So I guess a general question, just because I haven't thought it out, is therefore today, the current diesel powertrain, say a Class 8 tractor trailer, it has the tailpipe out emissions and the fuel fire heater emissions, whether it's just, overnight, or whether it's actually, I don't know if there's enough heat from the diesel engine that the fuel fire heater doesn't need to operate. But regardless, there could be instances where the emissions are both together and not just one or the other. So yeah, this is something that definitely in my mind needs to be addressed. One other clarification is that the EPA, the latest regulation by EPA on light duty vehicles, does include the fuel fire emissions in the overall standard, whereas a heavy duty vehicle regulation does not. So there is a requirement, or the emissions from that fuel fire heater is put through the after treatment on the vehicle, on the light duty vehicle.
Thank you for that. I think that is very insightful. And maybe since you and Kieran have been working together for a number of years now, if I can move to Kieran, and I was taking a look at the paper that you published with some of your colleagues last year, right? Where you found that depending on what emissions norm you look at, there could be some exceedances or not of that specific fuel fire heater that you tested. And I wonder if you could comment a little bit more on that, right? And we have three different standards that Shiyue was showing, right? One is per mile, the other one is average emissions, the other one is peak emissions. And if you could reflect on how the design of the standard influence that compliance of even low emitting fuel fire heaters.
Yeah, that is kind of it has a big effect on whether the heaters pass or not, right? And as I mentioned before, with the California standard, it's not based on any energy output of the heater. So if you have a larger heater, again, it will exceed that. So I think that's what happened in that case, where we had a transit bus that was running with a 23 kilowatt fuel fired heater, and it exceeded the standard in terms of NOx pretty consistently, just because it's larger than the heaters that are typically on a truck that are, say, 9 kilowatt or lower. Again, going forward with the EU standard being the peak value, it's kind of an interesting way to do it, where the test is actually an hour long, but the peaks when the heater starts are much higher than during operation. So you'll have say a peak in hydrocarbons for a split second, and that's how they're rating the heater, which to me doesn't seem like I mean, maybe as fair a system as there could be. The Chinese standard I have less knowledge of, but it seems like an average ppm limit would make more sense in terms of certain pollutants. For example, carbon monoxide. Again, that you see that real sharp peak at the start of each test, whereas something like NOx is much more consistent in what we've seen with our research, and consistently higher than the California standard would limit. So yeah, I mean, there's a lot of differences between those standards. What are one of my research goals for the next couple of years is to look at perhaps a different method of rating these, more based on power output rather than strictly ppm at the tailpipe, or an assumed amount over a distance. So I think that might be a fairer way to rate it, but we're still looking into how to create a test bench for that, and various other projects.
Oh, that's interesting. So it would be based on heat output, energy output, right? So a similar standard
Right.
as you have for kind of like engines, where you measure the power output at the shaft, but this would be for the heating output. That's
Yes,
interesting.
exactly. That's kind of my intent, but it's still early days on this.
Okay, okay, okay. Thanks for sharing.
Can I add something to that?
Please.
Okay, so I just wanted to note that in addition to this look at the emissions, there are several other things that Kieran has uncovered in terms of the operation, the application, the maintenance of these things, that are very important to include in requirements or designs. And I don't know if we'll get to that later in this discussion.
We can get to it now
Okay, all right.
if it's relevant.
Okay. All right. So we had so Kieran has tested several school bus, a transit bus, and a third one. I forgot right off the top of my head. But anyway, he bought some equipment in order
as well.
Okay, yeah, in order to measure the air to fuel ratio for these things, because there were some reports from people, school systems that had these buses that are seeing light smoke. And so, Kieran, why don't you go ahead? You know.
Sure. Well, it was also our own research. We uncovered that one of the heaters that we had been testing had very high PM emissions. We don't have, like Shiyue said, there's no standard other than the EU standard with the Bacharach number, which is you just kind of take a piece of paper, put it at the tailpipe, and see how dark it is. So we actually have tested our heaters on with particle number, like you guys did at the ICCT, as well as particle mass measurements, and we were getting numbers that were very high for the tailpipe of that heater, like higher than a diesel truck, as you mentioned in your presentation, Shiyue. And so we looked at that heater and we weren't sure what was going on, and we eventually purchased tuning equipment that's mentioned in the heater manual, and we found that the heater was set up to run very, very rich, which is not what you would like ideally with a diesel engine or a diesel heater in this case. So our latest research has been, we tuned the heater by adjusting the input air, and we saw that the PM emissions have gone down significantly. And anecdotally, I don't have numbers to back that up yet, but that's our latest research. And we were surprised that the bus manufacturer, after installing the heater, hadn't done this tuning. Maybe it's something they just don't know about. And the other aspect is that the heaters themselves, they only have a little fan that controls the airflow, and then the fuel is injected the same way, no matter what the airspeed is going in. There's no control on this particular type of heater, and it's very affected by the tailpipe length, the tailpipe diameter, and things like that. It's really important to tune the heater, and these ones don't have a feedback control of any type. Whereas there are some heaters on the market that do offer closed loop control, where they would control the amount of fuel injected or the fan speed in order to maintain a good air fuel ratio. So that might be something that's something that we also want to look at in the future, is to test one of those heaters to see what happens.
Yeah, that is super interesting. So I don't have even a fraction of the experience that you guys have with fuel fire heaters, but have an engines background, and when I was looking at these results, kind of like that was my first thought, right? We need closed loop control here. But also
Right.
maybe what are the possibilities of doing emissions control on these rather simple devices, right? So maybe, Katrina, you have experience with these technology demonstrators. Is there anything that you have seen where the emissions, where they have tried to tackle the emissions through some sort of after treatment system, or what's the state of the art when it comes to developing and deploying technology to treat these emissions?
Yeah, so like right now I'm looking at like a bioethanol heater and how that's running under real world conditions. Um, while it's in operation, there really isn't any after treatment. There's not that many emissions allegedly when you do a bioethanol heater. We're hoping to put it through its paces and, actually test it on the bench, but right now it's not looking like there's really any interest unless there's a regulatory body that's sort of pushing it that way. There's probably, a number of costs and complexities that would have to be added. So that's probably why they're not doing it like on their own. So that's kind of why this whole is really interesting to see how to make if it's possible to kind of make something regulatory to sort of push folks into considering sort of these niche very specific wanting control after treatment control. You just said it and I said it wrong. Looking at the how true or how pure it burns, like all of these things are like very fun, but I think we might be the people who care the most, and so how to take a step out and make sure that the findings and then the need is well put to regulatory bodies or what have you, so we're not just sort of all talking in a vacuum. So didn't really answer your question, but having a good time.
No, no, but I think that is insightful in any case.
I have
I'm
a,
gonna. Sorry, go
I
ahead,
have
Cheryl. Yes.
okay. So Katrina, the fuel fire heaters are used on ICE powertrains as well. So
Yeah,
it's not just for EVs. Okay, just for,
yeah,
I
no,
just wanted
definitely.
a question on you said it was a catalytic heater that you're testing with that biofuel, right?
Yes.
So most of the burners I think we've been talking about so far are kind of like Bunsen burner type. It's just kind of like a flame, that creates heat. So the catalytic one I understand is from a company I think in Sweden, or is this a different catalytic? It's basically you're using the heat from the catalytic process, right? To
Yeah, so
create.
you're getting to about the edge of my knowledge, because I'm not a mechanical engineer. I can pretend pretty well, but you're at about the edge of my knowledge here. But yeah, so essentially how it's been explained to me is they take like the first part of a fuel cell and somehow that creates heat. So they have a catalyst, and they have a heat exchanger, and then you have a little bit of exhaust. Um, but it's supposed to be better from an emission standpoint, and so that's why we're testing it just under real world conditions to understand if even if it's lower emissions, it can still handle the heat demand too.
Yeah, yeah.
So
So
yeah.
right. So that's I mean, so that's already has a catalytic process to it. So it's you, from the information we've seen online from one company out of Sweden, their emissions they show their emissions a lot lower than what a typical diesel fuel fire heater is. And it makes sense because catalysts create a lot of heat when they do their reactions, and so capturing that heat to provide the heat, for the heating of the cabin or the cab, that's one thing that Kieran and we hadn't gotten that far yet. So very
I understand.
interesting to find out what your missions are.
And that could solve a lot of the particle issues, right? Because I think the diffusion flame is what causes most of the particles to happen. So if you're doing some sort of catalytic oxidation of the fuel, maybe you can also get rid of the particles. Is that kind of like one of the advantages of this, or not necessarily?
One of the things that we found in terms of why the particulates are coming out is because the way the typical fixed fuel fire heater works is once it shuts off, there can be fuel dripping into the nozzle and into the canister, and so therefore when the next turn on of the fuel fire heater happens, you have this extra fuel, and potentially this fuel then turns to, or carbon can be developed as well. So you just have just the whole process of the way the fixed fuel fire heater works is just not very optimum. So you can have low particulates in other types of Bunsen burner fuel fire heater types. But the main thing for the catalytic based process, maybe Kieran has some more information on this.
I think they claimed that the particulate was really low, but we've never actually tested one because it's not on the market yet.
Right.
Okay.
We
Yeah,
can
they said-
talk more about that. We don't have to. I mean, I have a good relationship with the company we're working with, and they're really excited to see how it works under real world conditions, and they're very excited about their engineering prowess. So
Yeah,
we can talk. We could stick it in
that's awesome.
China too, see how it works. I don't know how it works over there, but why not, right? Give it a shot.
Yeah.
Uh,
And Shiyue, so we have here, and I see that you're typing an answer, but maybe you can share with the audience. We have a couple of questions for you here, right? So one that you already answered is on durability, right? And how
That's
fuel
right.
fire heaters are their emissions performance is influenced by age. Maybe not only to Shiyue, but also to folks who have experience, since we only tested the one, right? We don't have the trend. And maybe more directly to you is if you could explain a bit more how this simple control logic functions, right? And when what temperatures is it activated on, and what you saw during this, like the starting phase of the heating episode and the influence that had on emissions.
Yeah, I have to say that's it varies by region and by manufacturer or even by some fleet owners' preference at all. So because some fleet owners they want to have a warmer cabin, so they will change a little bit to the logic. But in general, that's a it depends on that um your cabin temperature. Like say in some cold regions in China, I learned that they will set like 16 or 18 degrees. That's once the temperature drops below that temperature, and the FFH just burned and will be burned and turned on. So yes, I have to say that maybe every driver has their own preference. So it will be highly different from bus to bus. So that's it. Yeah.
Right. And something that I remember when I was looking at kind of like the detailed results is that every time that one of these on-off cycles happens, right, you have an incredible high peak of emissions on particulates, on hydrocarbons, right, every time that the heater is started. And that also contributes a lot to the overall emissions, right, over that period.
That's right. That's right. Yeah.
Anybody else wants to contribute with the durability and aging question here, which I think it's very interesting.
Kieran, did you want to?
Yeah, we're sure. I'm not super sure about durability because the heaters that we've tested have been relatively new. The one that was in service that we tested for our paper, it had been used for I think 2 years, and it hadn't had any servicing done to it, so it was still doing well in terms of particulate emissions because it had been tuned properly. NOx emissions were a little bit high, but that's consistent with what we've seen with other heaters that have been new. So I'm not really sure how it will affect it as it ages. Maybe if that tuning gets out of alignment over time, that could have a large effect.
I will say
One-
that's interesting. Oh, sorry. You want to talk?
No, go ahead. Go ahead. Kieran.
I was just gonna say quickly, I had chatted with a number of transit agencies, and I actually got really interesting mixed results about like the maintenance of these little guys. I say little lovingly, because some people were like, "Oh yeah, we just let them go, like we don't worry about them." But some people were saying like we couldn't operate the bus because the heater wasn't working. And I'm not sure if it was like a different heater company or a different vehicle OEM or sort of what the discrepancy was, but I think it was really interesting that I got two very polarizing results about if it sits for the summer and nobody messes with it, or just one little thing gets disrupted that really throws the whole heating unit out of whack. Whatever you say professionally, it doesn't work, and so the bus can't run. So just something different too to think about.
And that's why the
They
closed.
mean that sorry. Did they mean that it was actually interlocked and that the bus wouldn't let it run if the heater wasn't working properly, or they just couldn't run because it wasn't heating and people would have been cold?
So from a technology perspective, the bus could run. From a driver and
Okay.
passenger perspective, they were not
Right. Okay. Got
interested.
it.
It's very
Got it.
cold, and they didn't want to get on that bus.
Yes, that's fair.
Cheryl?
Yeah, so just to note that there are different types of fuel fire heaters. There are ones that are on and then off, and there's ones that are on and then have a lower setting so that they're not high all the time. So the emissions, if you run it max on, that might not be its emissions through its actual use. It could have, like the 5.6 kilowatt heater, it had, well, another stage where it used only half the amount of fuel. There is a advanced fuel fire heater technology which has the closed loop control. It basically is on all the time, but at various fueling rates, depending on how much heat the cooling system is needed. So therefore, you don't have the spike on, you don't have a lot of on and offs. It's just one, slow heat consistently. And then it also has an afterburn. So that way there's no leftover fuel at the tip of the nozzle or in the combustion chamber. So, and then there's this catalytic design, which I think are just being discovered or understood, which may be a solution to all this, but
Okay.
anyway, yeah.
Great. So we're nearing the end of our session. So thank you so much for all that expertise that you brought to the table and for sharing those insights. I know that the group of people working on fuel fire heaters around the globe is rather small. So I hope that we can do another one of these and get folks together. We're missing a European representative. Unfortunately, we were not successful in securing that participation, but maybe for the next time that we do one of these, we can, since there's some research happening here in Europe as well. In Finland, for example, there is an organization, and in Sweden doing this type of research. So, but until then, thank you so much for your participation. Thank you to the audience for those good questions and for following through. And I wish you all a very nice rest of the day, a very nice evening. Shiyue, please go home. I didn't know that you were going to stay in the office until this late. So thanks for doing that, and good rest of the day for those of you in the Americas. And well, thank you so much.
Thank you very much.
Thank you so much to all.
Bye-bye.
Bye-bye. See you.